We talked way back in Module 1 about taking a segment and finding the point that divides a segment into two congruent segments, and that point was the midpoint. In this lesson, we're talking about finding a point that subdivides a segment into any ratio. So they start us off with this activity. We have the exit for Arthur Avenue at mile marker 14, and that we want to label as point A. So 10, 11, 12, 13, 14 here is A at mile marker 14. Exit for Collingwood Road is at mile marker 44. We're going to label that point C, and that's at 41, 2, 3, 4. So here is C at mile marker 44. The State Highway Administration wants to put an exit for Briar Street at a point that is 2/3 of the distance from Arthur Avenue to Collingwood Road. So in part A, they wanted us to label the points. We've already done that. In part B, what is the distance from Arthur Avenue to Collingwood Road? And the way I want you to think about this is, since I'm going from Arthur Avenue to Collingwood Road, I start with the coordinate for Collingwood Road, subtract the coordinate for Arthur Avenue, and I get 30. How far will the Briar Street exit be from Arthur Avenue? Well, I want it to be 2/3 of the distance from Arthur Avenue to Collingwood Road. Well, I found the distance from Arthur Avenue to Collingwood Road to be 30, so 2/3 of 30 is 20. So where will the mile marker be? It will be 20 plus the mile marker number for Arthur Avenue. The Arthur Avenue mile marker is 14, so it will be at 34. At 31, 2, 3, 4. The Highway Administration also plans to put an exit for Dakota Lane at a point that divides the highway from Arthur Avenue to Collingwood Road in a ratio of 2:3. What is the mile marker number for Dakota Lane and why? And they're giving us a hint, so let's use it. They're saying let the distance from Arthur Avenue to Dakota Lane be 2x, and then the distance from Dakota Lane to Collingwood Road be 3x. Well, the distance from Arthur to Dakota Lane plus the distance from Dakota Lane to Collingwood Lane would be the distance from Arthur to Collingwood, and we already figured that's 30. So when we solve this equation, we've got 5x equals 30, so x is 6. So that means that from Arthur Avenue to Dakota Lane, if I call that AD, that's going to be 2x, which is 2 times 6, which is 12. Now, 12 isn't the mile marker. 12 is the distance from A to D. So from A to D, I have 12 plus 14 is 26. So 21, 2, 3, 4, 5, 6. And that's my mile marker. And my Y is kind of shown there. And we've already plotted and labeled Dakota Lane exit on the number line. Would our answer in step F be different if the exit for Dakota Lane subdivided from A to Collingwood in a ratio of 3:2? Yes, the answer would be different. AD would be 3x, or 18. So D would be located at 18 plus 14, which is 32. This concept of a directed line segment that we're using in this lesson is very similar to a concept that we used back in the beginning of Module 11 when we didn't want to use distance formula to compare the lengths of various different segments, and so we talked about the rise over run for those segments. We're kind of doing the same thing here. Since, however, we're talking about it specifically from A to B, now we do have the prospect of possibly having a negative rise or a negative run. So in the instructions for part A, I'm trying to find the point on segment AB that subdivides it into a ratio of 3 to 1. So they've taken 3 over 3 plus 1, and what we're finding is the point that is 3/4 of the distance from A to B. So they found the run, they found the rise. One way that you can think about these values, this is x2 minus x1. This is y2 minus y1. And then we took 3/4 of the run, took 3/4 of the rise, and then we added those values to the x-coordinate of A. So they took this 12, you see it here. They took this 9, you see it there. And the -8 and the -7 are the coordinates of A. Part B, we're doing a little bit more on our own. Write a ratio that expresses the distance of point P along the segment from A to B if I'm trying to find the point that divides AB in a ratio of 1 to 2. So that's 1, 2, 1 plus 2, which is 1/3. So I want to find the point that is 1/3 of the distance from A to B. My run is 2 minus -4, which is 6. My rise is 1 minus 4, which is -3. And so point P is 1/3 of the distance from point A to point B. So 1/3 of the run is 1/3 of 6, which is 2. 1/3 of the typo alert rise is 1/3 of -3, which is -1. Now I'm taking the x-coordinate of P, which is -4, and adding 2 to it, so I get -2. The y-coordinate of point P will be, well, the y-coordinate of A was 4, so 4 plus this -1 that I found here, so that's 3. My answer, therefore, is -2, 3. And if we plot it, let's plot the original segment too while we're at it. Here's A, here's B, and I just found that -2, 3 is the point that divides the segment in a ratio of 1 to 2. What can we conclude about a point that partitions a segment in the ratio 1 to 1? Well, if it's breaking it in a ratio of 1 to 1, then it's 1 over 1 plus 1, which is 1/2. Well, then it's dividing the segment in half, and we talked earlier about how this is the midpoint. How would you find the coordinate of such a point? You would use the midpoint formula. x1 plus x2 over 2, comma, y1 plus y2 over 2. In the Your Turn example number 5, we're asked for the coordinates of point P that divides segment AB in a ratio of 5 to 3. So 5 to 5 plus 3. So I'm actually finding the point that is 5/8 of the way from A to B. So my run from A to B is 2 minus -6, which is 8. My rise from A to B is -3 minus 5, which is -8. I take 5/8 of 8, and that's 5. I take 5/8 of -8, and that's -5. And so I take my A coordinate, and I get -6 plus 5, comma, 5 plus -5. And when I simplify this, this is going to be my answer. It's -1, comma 0. You might want to pause your video a moment to copy everything from here, because I need the rest of the screen in order to do problem 6. In problem 6, I want to find the point that divides at segment AB into a ratio of 3 to 2. So that means I'm trying to find the point that is 3 over 3 plus 2 the way from A to B. My run from A to B is -6 minus 4, which is -10. My rise from A to B is -13 minus 2, that's -15. I take 3/5 of each of those values, so 3/5 times -10 is -6. 3/5 of -15 is -9. And then you're going to take each of these values and add them to the coordinate of A. So P is located at 4 plus -6, comma, 2 plus -9. That means P is located at -2, comma, -7. In the last part of our lesson, we're looking at how to subdivide a segment into a certain ratio using our compass and straight edge. And so you see how they have the steps laid out for example, I don't know what example this is, part A. And we start with a segment, and then notice that we've drawn ray AC. So what we're forming there is an angle. And what we're eventually going to form is a triangle. Now, the shape of the triangle isn't necessarily important, but that starting angle formed by the segment that you're partitioning and the extra ray that you add, a nice acute angle like what they've drawn here is ideal. And so you see in step 2 that we're going to partition ray AC in 3 different arcs. Now, notice that the point C is kind of irrelevant. The arc setting that you're using on your compass in order to mark D, E, and F, those aren't important. They're random, right? So, let me get my compass. So using our compass, I put the compass point at A, open my compass to pretty much a random setting. I just don't want it to be too big that it goes off of AC. So I'm breaking this into 3 segments, D, E, and F. So, or 3 points, excuse me, D, E, and F. So there's D, E, and F. My next step is to connect F to B. So now I have a triangle. Notice also that I have an angle AFB. And if I construct an angle at E congruent to angle AFB, then I will have formed parallel lines. Okay, so that's our next step. So So in order to construct an angle congruent to a given angle, remember you make a random arc through your given angle, duplicate it at the point where your new vertex is going to be. Then, using your compass, you're measuring the distance between these 2 points on the arc that you just formed. So make sure that you're noticing what I'm measuring here. I'm trying to. The distance between those 2 points. So now that I've got this compass setting, I'm going to take this compass setting and duplicate it from where my other compass marking crossed ray AC. And it crosses it here, and darn it, I didn't make my first arc big enough. Little human error, never hurt anyone. Let's just redo that. Okay, so where those 2 arcs intersect is here, and I'm going to draw a ray from E through that blue point, and get a parallel line to FB. Now what you could do is construct another congruent angle at D. You don't really have to do that. What you could do is take your compass and use it to measure the distance from B to this point that we created here. And mark that off. From here. And so what I've done now, and it might be a little bit flawed, again, human error, but the idea is I've broken this segment AB into these 3 parts. And on a test or quiz or on the EOC, it's not the precision of your instrument that is most important, it's your understanding of the steps. All right, so let's call this point maybe H. So AH is 1/3 of AB, approximately. Part B, they're asking us to divide AB into a ratio of 1 to 3. So remember, 1 to 3 means 1 over 1 plus 3, which means I need to break this segment into 4 equal parts. Make an angle. Divide my ray, or not divide my ray, but put 4 equidistant arcs on ray AC. So 1, 2, 3, 4. And I made this a little bit flawed. I'll try doing this again. Okay. Connect my last arc to B. Now I've got a triangle, and I'm going to make from this point an angle congruent to angle ACB. I do so by making a random arc through angle C that I then duplicate at this new vertex of an angle. Use my compass to measure this distance. And then duplicate it from here. So that now from this point through that intersection, there's a parallel line. And I can take my compass, make it the distance from this new point to B, and I can mark that distance off 1, 2 more times. And now you see that AB has been subdivided into 4 equal parts. And let's call this X. AX would be 1/4 of AB. In part A, why is EP parallel to FB? This point was the point P that they're referring to. They're parallel because we constructed a corresponding angle to angle AFB that was congruent to it. So the reason why they're parallel is the converse of corresponding angles theorem. How could we use triangle proportionality theorem to explain why this construction method works? Since AC is subdivided into congruent segments, and the last point is connected to B, to form triangle ABC, in which parallel lines are drawn through it, AB is also divided into congruent segments.